Hello everyone and welcome back. This is going to be a short video introducing guardrails. So whenever you're working with LLM applications, building chatbots, coding assistants, or anything that interacts with users, you want to make sure that your system behaves reliably, ethically, and within the scope of your project. So until this point, the way we've been doing this is through prompt engineering. You basically tell the system everything you want from it, everything you don't want the system to do. So whatever your instructions are, you put them into the prompt. And this is not the most reliable approach because the users are also free to input whatever they want into the prompt. And they might input something that contradicts your original instructions, and whenever there is a contradiction, the behavior of the LLM is kind of unpredictable. So we want another way, another systematic way, something that mimics how it's happening in software engineering tests. So imagine that you have a testing function, something that runs over the input to the LLM and the output from the LLMs. So there should be a function that runs and it either passes or fails, and it gives you a reason of why did it pass or fail. So in this lesson we will take a look at this, and we will use a package called Guardrails AI. And yeah, let's take a look at some of the examples. So for this lesson we've prepared some examples. So we have a toxic example that starts with a language that's not it's not friendly. So it's kind of cursing the AI that it's using. So this is what we call toxic. And we have another prompt that's called unusual. So you can see this part is very normal, and then here it starts telling the LLM to generate false and misleading information, fabricated statistics, and so on. So all of these instructions are like harmful instructions, or the user is trying to do something that's not what is supposed to happen. So we have these two. So one is toxic, one is unusual, and we'll also be using one prompt that we introduced in the previous weeks. So this is a normal prompt. So we want to show how a normal prompt would pass these checks while the other two should fail. So let's take a look here. So we're using the A3 graph, which is the system we introduced in the previous week or the previous 2 weeks, and we want to validate whatever is going into this system. So to do this, we have a validate input function that takes in the input of the user. In this case, it's going to be the content from these files, and it's running the guard class, and it's picking. We are picking two of the guardrails to use. So I'm importing this from the guardrails package. You'll find the links for this package in the publication, and yeah, we've picked two of these guardrails. One is called ToxicLanguage and the other is UnusualPrompt. So before we run this, I want to tell you how these things run. So basically it's a function that will run, and it either passes or fails, right? So the question might be, what are the content of these functions? So for example, they don't have to be LLMs. This is what I'm trying to say. For example, the ToxicLanguage class, it's actually using a deep learning model, an encoder model, which is basically a classifier. So someone trained a classifier to be able to classify language as either toxic or not. So this is binary classification, and that's why it has a threshold parameter. So whenever the prediction or the predicted probability is larger than 0.5, it's going to be flagged as toxic language. So this is an example of a guardrail that uses a deep learning model inside of it. While here the unusual prompt, I checked the source code of these two, so feel free to do the same, but the unusual prompt is using a LLM. So inside of here there is another LLM running with a prompt that's basically explaining what it should do. So I can quickly show this to you. So here I'm inside the unusual prompt class, and you can see it's using GPT 3.5 as a default. And yeah, here's the prompt. So yeah, you can read it on your own, but yeah, this is an example of a guardrail that uses an LLM. There are other guardrails out there also that use deterministic code, whether it's a regex function, for example, whether it's a validator that validates the output format. So some of these are there to check that the output of the LLM is CSV, for example, or is a SQL query. So these are other examples of things that can be deterministic. These are it can be something else other than a deep learning model or an LLM. So now we can run these two guardrails on our input, and here we have three different examples: toxic, unusual, and normal. We will start with normal, meaning that we will be loading the normal prompt, which has no problems. It should go into our system. And the way this is happening is we run the validate input on the text that we have before going into the system. So guardrails here is something that we run over the input or the output of the system. And in this case, it's running before the system runs. So it has nothing to do with the internal state of the system or the prompts of the system itself. So we're loading the normal prompt, and let's run this and see what happens. So you can see the graph is created and it will start running. So let me stop execution and yeah, try something else. Let's do toxic. So this time I'm loading this example, which is being mean to the LLM. So you can see it threw an error, and it's saying that it failed because the following sentence were found to be toxic, and it's highlighting this part. We can do the same with the unusual. So again, it errors and it says that it found an unusual request being made. So in this case, it's throwing errors because we're specifically telling it to throw errors if it fails. So in this application, you might want to provide something to the user, right? It failed, and you give the user some kind of a message on why this failed. Or in some other cases, it might be failing because of a hallucination of the LLM itself. So you might want to provide this feedback itself to the LLM again. So yeah, it depends on your use case. But yeah, there are different ways to handle this. So yeah, that's it for this video. I hope you found that useful, and I'll see you in the next video.